I will explain why the World Marrow Donor Association needs an expanded algorithm that accommodates searches of non-Western descent donors. Allogeneic hematopoietic stem cell donors are needed for patients with hematological malignancies, the so-called leukemias, and also for patients with non-malignant hematological diseases, such as aplastic anemia, immunodeficiencies, and some inborn errors. The challenge is to find the best matched donor amongst many donors. Donors are primarily selected on compatibility for human leukocyte antigens, the so-called HLA. HLA matching is done on HLA-A, B, C, DRB1, and often also on DQB1. Now, HLA is very polymorphic. This means that there are many different HLA types. And the frequency of the various HLA types differ in the different ethnic groups. For patients in need of an allogeneic hematopoietic stem cell transplantation, the first choice is an HLA identical family donor. But only about 25 to 30% of the patients have such an HLA identical donor. And this means that over 70% of the patients, an unrelated donor is needed. There are over 30 million donors in the Search and Match and Connect service of the WMDA. And these are donors from 54 countries. Now the question is, how do you find the HLA matched donor amongst the 30 million donors? Well, the answer is you need a matching algorithm. As I already said, without a matching algorithm, you do not know which donor to choose amongst the many donors available. Now there are two matching algorithms. There's the standard matching algorithm, which is the original matching algorithm used for the Search and Match service. And there's a new matching algorithm, and that is based on probability. The matching algorithm needs to take into account that not all donors are fully typed for HLA-A, B, C, DRB1 and DQB1. And also, not all donors are typed at the desired high resolution level. Many donors are typed only at low resolution level or at intermediate resolution level. And the fact that donors are not completely typed makes selection of the donors that will turn out to be HLA compatible with the patient very difficult. I will first explain the standard matching algorithm. Here you see the HLA typing of the patient on top. And the patient is typed for HLA-A, B, C, DRB1 and DQB1 at high resolution level. Now there are two potentially matched donors for this patient available. One from the Netherlands, NL, and one from Great Britain, GB. Now say you are only allowed to choose one of these donors. Which one would you choose? The NL donor or the GB donor? Well, we can see that the NL donor is typed at a higher level than the GB donor. The XX means that the typing is performed at low resolution. It means that it can be any variant. For example, A11XX from the GB donor can be an A1101 or an 1102 or an 1103, etc. And you will only know if this is an A1101 like the patient has once you've typed the donor at high resolution. Now the NL donor is typed at a higher level than the GB donor. Should you therefore choose the NL donor? Without a probability matching program, one would be tempted to choose the NL donor as this donor is typed at a higher level. But should you have the probability matching program, it can tell you what the chance is that the NL donor will be fully matched with the patient after high resolution typing, and this is only 3%, while it will tell you that the GB donor has a matching probability of 90%. So it is clear you should have chosen the GB donor over the NL donor, but with only the standard matching program you would not have known this. First of all, many of the donors are not typed at the resolution desired. This leads to ambiguity and uncertainty about the real match rate of such donors, as shown in the previous example. Standard matching relies on the knowledge and skills of search coordinator to predict which donors might be matches once they are typed more extensively. Now, what is the reason for probability matching? Well, huge and still increasing polymorphism of HLA makes it difficult for search coordinators to predict matches. Extensive knowledge of HLA is needed. It's difficult to choose donors with the highest chance to match with a patient when there are many incompletely typed donors. And probability matching uses the knowledge to predict which donors have the highest chance to match with the patient. Now, how does the probability matching work? Well, it estimates the HLA-A, B, C, DRB1 and sometimes DQB1 haplotype frequencies based on the phenotype data of the population. It calculates the likelihood that patient and donor match using the estimated haplotype frequencies. And it considers allele association over complete haplotypes. Now, this is an example of the probability matching results. If we look at the first donor, there's a 99% chance that the HLA-A alleles, the A11 and the A24, are A1101 and A2402 and are therefore identical to the patient's HLA alleles. For HLA-B, it is a 95% chance that the HLA-B alleles will be identical to the patient. For HLA-C, which is not even typed for, the probability match is 85%, and for DRB1 it's calculated to be 96%. The HLA-DQB1 of the donor is already typed at high resolution and is identical to the patient, and therefore it is given as a 100% chance. And altogether, the probability match is calculated that this donor has an 82% chance of being A, B, C, DRB1 and DQB1 matched with the patient. And there's an additional chance of 12% that this donor has a single mismatch and another 5% chance that there will be two mismatches. The first improvement to the matching algorithm was the implementation of the probability matching algorithm. The implementation is based on HLA haplotype frequencies of all donors in the search and match file. And as the majority of the donors are of non-Western descent, it worked well for these donors, but not for non-Northwestern descent donors. A second improvement to the matching algorithm was made. The haplotype frequencies were calculated on the different countries rather than on the entire file of the donors. And this has improved the matching results for the non-Northwestern descent donors significantly. The probability matching algorithm is especially helpful for searches of non-Northwestern descent donors, as these donors are often not fully typed, and the donors from non-Northwestern descent originate from many different countries. And the HLA types in the different countries vary enormously. Now, to have knowledge of all these different HLA types is practically impossible for one person. And this makes selection of donors from non-Northwestern descent with the standard matching algorithm especially difficult. The probability matching algorithm can predict the likelihood that a donor will be matched based on the phenotype frequencies of a particular ethnic group. In conclusion, the probability matching saves time and leads to better donor selections, particularly if donors are from non-Northwestern descent, and these need to be selected.